Hi students, now we are going to discuss about aromatic aldehydes, ketones and carboxylic acids. Next in this chapter we are going to discuss about the preparation and properties of benzaldehyde and acetophenone. Now discussed elaborately about benzaldehyde. Benzaldehyde is also found in nature as the glycoside amygdalin in bitter almonds. What are the preparations? First preparations from toluene. Benzaldehyde is prepared from toluene, undergo oxidation using chromium trioxide and in acetic anhydride. So the toluene CH3, the two hydrogen is removed from toluene and the remaining two group of acetate is attached to that CH carbon. So then will be converted into benzyl acetate. The benzyl acetate undergo hydrolysis with hydrochloric acid or sulfuric acid. We get a benzaldehyde. The remaining oxygen is attached to the CHO group. The OH is attached to the CH3COO group. So we get two molecules of acetic acid. Next preparations from benzyl chloride. Benzyl chloride is also undergo oxidation using nitric acid in presence of lead nitrate, and this combination of the solution is just boiled. Then we get a benzaldehyde. The from benzyl chloride, the HCl is removed, the oxygen is attached to that benzyl chloride. Then only we get a benzaldehyde. Next preparation, hydrolysis of benzyl chloride. Benzyl chloride is undergo hydrolysis, then only we get a benzaldehyde. So the hydrogen from water molecule and the chlorine from benzyl chloride, these two combinations leave us HCl as a byproduct, we get a benzaldehyde. Another preparation, Caterman-Koch reactions. In this reaction, first we have to take equimolar mixture of carbon monoxide and hydrochloric acid is bubbled through a solution of, that is ether solution of benzene, then only we get a formyl chloride. This formyl chlorides undergo react with benzene, we get a benzaldehyde. So hydrogen from benzene, the Cl from formyl chloride, these two combined leave as a byproduct as HCl. The remaining CHO group is attached with that benzene ring, then only we get a benzaldehyde. Another one of the naming reactions, Gatterman aldehyde reactions. But this is also one of the preparation of benzaldehyde. Here we have to take a HCl and hydrogen cyanide. We get a formimidochloride intermediate. So in hydrogen cyanide, C triple bond N, one of the bond is break from that. The hydrogen is attached to that nitrogen atom. The remaining chlorine is attached to that carbon atom. We get a formimidochloride. The second step, the formimidochloride is attached to that benzene. Hydrogen from benzene and the Cl from formimidochloride. These two are combined, leave as a byproduct. Then only we get imine. These reactions are undergo using a catalyst aluminum chloride. The imine is further undergo hydrolysis using water molecule. Then only we get a benzaldehyde. The C double bond NH group. The NH group is abstract proton from hydrogen. This leaves ammonia NH3. The remaining oxygen is attached to that imine group. Then only we get a benzaldehyde. Another one of the preparation of naming reaction, Roseman reaction. Here we have to take a starting amount as benzyl chloride, undergo reduction using a palladium barium sulfate catalyst. We get a benzaldehyde. The H is removed as HCl. H is subtract proton, removed as HCl. The remaining hydrogen is attached to that carbon atom. Then only we get a benzaldehyde. Another one of the naming reactions, Stephen's reactions. Here benzyl cyanide undergo reductions with hydrochloric acid and stannous chloride. We get a aldehyde complex. This is on subsequent hydrolysis yield benzaldehyde. Another one of the preparations from Grignard reaction. Preparation of benzaldehyde from Grignard reactions. In these reactions, phenyl bromide react with magnesium. In presence of ether, we get phenyl magnesium bromide. This is on further reacting with ethyl formate. But from the ethyl formate, the CHO group is attached with that phenyl magnesium bromide. The MgBr is removed, abstract OCH5 group, then only we get benzaldehyde plus MgBr OCH phase leave as a byproduct. Next we are going to discuss about physical properties of benzaldehyde. Benzaldehyde is a colorless oily liquid boiling point 179 degrees centigrade. Its odor is like a almond. It is slightly soluble in water but readily dissolved in organic solvents like ethanol, diethyl ether, etc. It is also steam volatile. When heated benzaldehyde, the steams are easily evaporated. And next we are going to discuss about the chemical properties. Benzaldehyde undergo oxidation in UV light, we get a benzoic acid. Oxidation means addition of oxygen. So the oxygen is added to benzaldehyde, we get a benzoic acid. Another reduction, benzaldehyde undergo reduction, see in presence of zinc hydrochloric acid, we get a phenyl alcohol. Here also hydrogen is added to that benzaldehyde, we get a benzyl alcohol. The another one of the reduction process, we get a diphenyl pinacol. Another reactions, the hydrogen cyanide is added to the benzaldehyde. In presence of sodium cyanide, we get a mandalonitrile. So the C double bond is breaked. Then it is ionized as a C plus and O minus. The HCN is act as H plus and Cn minus. So the H plus is attached to the O minus. We get OH. The remaining Cn minus attached to the carbon atom, C plus of carbon atom. Then only we get Cn. So that is mandalonitrile. This is further hydrolysis with HCl. We get that is mandelic acid. The Cn group is hydrolysis. We get the COH. That is mandelic acid. Another reactions, that is addition of sodium bisulfate. Sodium bisulfate is added to benzaldehyde. We get benzaldehyde sodium bisulfate. The C double bond OC plus and O minus. The bond is breaked and act as a C plus and O minus. So the H is attached to that O oxygen group. The remaining sodium plus SO3 is attached to that carbon atom. And the final product yield is benzaldehyde sodium bisulfate. Another reactions, this react with hydroxylamine. This benzaldehyde is react with hydroxylamine. The water molecule is removed. The oxygen from benzaldehyde, the hydrogen from hydroxylamine. That is combination. These two are combined, leave us a water molecule as a byproduct. The remaining NOH group is attached to that C double bond O group. We get a benzaldehyde. So the another reactions, benzaldehyde is react with phenyl hydrazone. This is same process carry out. The water molecule is also removed. The remaining NHCCH5 group is attached to that C double bond O group. We get a phenyl hydrazone. The water is leave as a byproduct. Water molecules leave as a byproduct. Next properties of benzaldehyde. That is benzaldehyde react with phosphorus pentachloride. Here the water molecules removed from carbon atom. The chlorine is attached with that carbon. We get this gem halide. This is gem dihalide means we get benzyl chloride. The remaining POCl3 is leave as a byproduct. The upcoming reactions are only carry out the aldehyde group. So the reaction is react with ammonia. So it's not the benzal does not give the simple benzyl aldehyde ammonia complex ammonia reactions. The only we get the complex formation. So the nitrogen is attached to the C double bond O group. The remaining oxygen is abstract proton. We leave as a water molecules. We get more complex formation of CCH5 CH double bond NH. Another remaining and the same group is attached to that alternately the number of times, then only we get a complex formation that is known as the name hydrobenzaldehyde. Another reactions, benzaldehyde is react with primary or there is aromatic amine, known as the naming reaction as a Schiff's base. So here benzaldehyde is react with that is N-methyl aniline. So the water hydrogen from N-methyl aniline and oxygen from benzaldehyde, These three are combined, leave as water molecule. The remaining NCH3 groups attached to the C double bond O group. We get the N-methyl benzylidine imine. So another reaction is also aniline. The aniline also the same reaction carry out. The water molecule is removed. The remaining NCH5 is attached to that C double bond O group. We get the benzylidine aniline. Water is leave as a byproduct. Next we are going to discuss about detailed discussion of acetophenone. First we are going to discuss about preparations. We have to take the equimolar mixture of calcium benzoate and calcium acetate. On heating, there is acetophenone is produced. The calcium carbonate is leave as a byproduct. Another preparation, benzene react with acetyl chloride. Hydrogen from benzene ring abstract chlorine leave as HCl. Remaining part of CH3CO group is attached to that benzene. We get acetophenone. Another preparation, ethyl benzene undergo oxidation at 120 degrees centigrade and pressure. We get acetophenone. The second carbon having CH2 group is abstract oxygen, leave as a water molecule. The remaining oxygen is attached to that second carbon. We get a C double bond O. So as that ethyl benzene undergo oxidation yield acetophenone. Next we are going to discuss about physical properties of acetophenone. It is a colorless crystalline solid melting by 20 degrees centigrade, boiling by 202 degrees centigrade. It is smell like hay leaves. It is sparingly soluble in water but readily dissolved in ethanol diethyl. It is also steam volatile solid. When administered orally, it is of sleep produces a natural type of sleep. Next, chemical properties. Acetophenone undergo oxidation produces benzoic acid. Reduction, another property is reduction. Acetophenone undergo reduction with sodium ethanol. Hydrogen is added to that oxygen and carbon. We get that is methyl phenyl carbonyl. This is secondary alcohol. Another reduction with zinc amalgam and hydrochloric acid, we get ethyl benzene. The second carbon having oxygen, that oxygen is removed, attached with that hydrogen to the second carbon, then there is yield ethyl benzene. Another property is chlorination. Acetophenone undergo chlorination and the H is removed and abstract chlorine leave as byproduct as HCl. The chlorine is attached to that first carbon. We get phenacyl chloride. Next, condensation. We have to take 2 moles of acetophenone. Condensation itself produces diphone. That is water molecule H from one of the acetone, hydrogen, 2 hydrogen from another acetone, combine to leave as a water molecule. So the C double bond, the remaining CH2 group is attached to that C double bond O group. We get diphenone. Next naming reaction is Wilgerat reactions. This is we have to take equimolar mixture of acetophenone and sulfur and primary amine is heated. We get a thioamide. This thioamide is further hydrolysis produces phenyl acetic acid. This is named as this total overall reaction is called as a Wilgerat reaction. Another reaction, so that is Manich reaction. This is one of the properties of acetophenone. Acetophenones are having this alpha hydrogen to the carbonyl group. This acetophenone is reacted with formaldehyde and ammonia, produces beta amino ketone. This is the product is named as a Manich base. The overall reaction is called as a Manich reactions. So next, uses of acetophenone. It has been used in perfumery industry. It is perfume and also used as a hypnotic under the name of hypnone. It is hypnone means it is great in sleeping. So nowadays, but now it has been replaced by more effective drugs.